Okay, hello. I am Mike Mensch, Business Development Manager at Princeton Consultants. Thank you all for joining us today, and thank you to our partner Garobi for co-sponsoring this webinar in which Irv will be discussing best practices in optimization, solution development, and deployment. We will be taking questions at the end of Irv's presentation. You could post your questions in the Q&A via the icon at the bottom of your Zoom control panel. We will be emailing Irv's slides after the webinar, so you can look forward to that. And on that note, I will turn it over to Irv.
All right, thank you, Mike. And thank you everybody for joining us today. So we're at Princeton Consultants. I'll say a little bit about more of us, but I also want to acknowledge Groby and co-sponsoring this webinar with us. We are a premier partner, service partner with Garobi. Proud to have that designation. I've done a number of client projects for their clients. So a little bit about Princeton. Our roots are in information technology and management consulting. We started off as a management consulting firm 45 plus years ago. We have a main office in Princeton, New Jersey, and another office in Midtown Manhattan. We started off worrying about things like strategy and process improvement, and then discovered that optimization and now AI can help people make better decisions. And we end up developing full-scale applications that help people apply these technologies to transform their businesses. Our clients span multiple industries. We do a lot of work in transportation. Not all of our work is AI optimization based. A lot of times it's just about transforming people with better information technology. But really in all verticals, I'm currently doing work in healthcare right now and supply chain. So it's really all over the map. We've done many successful completed projects. Our senior staff have been here quite a while. Our CEO jokes that I brought down the average, although I've now been at Princeton for over 10 years. And our mission, again, is to help clients accelerate their digital transformation. A little bit about myself. So as I mentioned, I've been at Princeton for about 10 and a half years now. After teaching at Princeton University, I joined CPLEX as one of the original developers of CPLEX, moved on to product management and marketing roles. Eventually, at the time that IBM was acquiring iLog, I was the vice president in charge of iLog Direct, which was the channel responsible for selling iLogs and doing outbound marketing of iLog's optimization and visualization projects. Then at IBM, I helped make the transition in the business side, and then returned back over to my roots of being a mathematician by working in IBM research, looking for ways to combine predictive and prescriptive analytics. I was one of the first in the first cohort of certified analytics practitioners from Informs. I've also been elected as an Informs fellow and as a senior member of Informs, which just means I've gotten a little old. I'm also on the Pandas steering committee. I'm a big proponent of using Pandas to manage data, and I found it helps accelerate our optimization solution development. So what I want to start off with today is a project that I collaborated with some other Informs colleagues to create what's now called the Informs Analytics Framework. And this actually started back when the CAP program began in 2013. There was what was called the job task analysis. And there was a team, I was not involved in that kind of created these domains you see here on the screen to develop what do typically analytics practitioners do? And that became the basis of the Certified Analytics Professional exam. In the past, about a year and a half, the Informs has worked to update that job task analysis and rebrand it as a framework for applying analytics. And that analytics can span from simple dashboards to doing machine learning to doing optimization, and even for AI projects. And so in this revision that we worked on in 2024, we updated the domains and the various tasks that are associated with those domains, and also defined testing objectives that are for the new three levels of the CAP exam. So there's an essentials level that is for people who are beginning their careers, a mid-level for people who've been about 5 or so years in, and then an expert for people who've been doing it a long time. Anybody who was a CAP before became an expert automatically. And so this is now serving as the basis for creating new exam questions for the different levels. And we'll talk a little bit about that later. But one of the other things that came out of the job task analysis, which is now the analytics framework, is that we found that people started to use it as a way of looking at, as a way of being successful in analytics projects. We also found that in universities, people were teaching to it. They were teaching their students, these are the things you should be thinking about if you're doing an analytics project. So in classical operations research programs, you had people mostly worried about these domains 4 and 5, picking an approach and how to develop a model. But as we and in the CAP community have learned over time that all of these domains are important. So what I want to first do today is go over these domains because it turns out they very much align with the way that we here at Princeton approach our optimization projects, in that we concern ourselves with all 7 of these domains when we do a project. So the first domain, which is probably the most important, is framing out your business problem. And so the idea here is that you really need to start, if you're working on an optimization problem or any analytics problem, is understanding what is the problem you want to solve? What is the question that's being asked? So you first develop an initial statement of that business problem, then identify all the stakeholders and their perspectives. So who are the sponsors? Who's going to be affected by a potential solution? Then you have to say, is this problem question amenable to an analytics solution? We've actually done projects where we've been called in for our optimization expertise and discovered, somewhat due to our management consulting roots, that the solution to the problem was changes in business processes, and that those had to happen first before any analytics or optimization could be done. Then as you do this and you're having discussions about it, you make sure that this initial business problem in question is clear and concise, and then work on a business case. And the business case means that, is this, if you were to create a solution, what is it going to cost to create the solution? What will be the benefits of that solution? What are the effects of this solution on the organization? We'll touch a little bit more about that later in the presentation. And finally, before you move on to doing any form of analytics or optimization, you want to make sure that everybody who are the key stakeholders and your sponsor agree that this is the problem that you want to solve, or the question that you want to answer. The second domain is about analytics problem framing. So now you want to say, I've got a business problem. How do I want to think of it as an analytics problem? So you're going to reformulate the statement of the business problem or question as an analytics problem statement, saying, so sometimes you have to make assumptions of things that in order to apply the analytics, you maybe have to make assumptions of things that are in the business problem for you to be able to handle it. You want to understand, not at the data level, but more at a conceptual level, what are the different drivers or inputs that are driving a potential solution with analytics, and what are the outputs that you need to create? Again, this is at a more of a business level, as opposed to saying, I need to create this table with these values. Then you want to make sure you understand the assumptions related to the analytics problem for how the analytics will be applied. And you want to define your primary measures of success. In this case, in the first case with the business problem, you're worried about it at a financial level, or at other levels of benefits. Here you're trying to say, well, how will we measure this? How do we actually, because analytics is typically about doing numbers. So how will you measure that the analytics problem statement that you've come up with is delivering value? The next thing is, what is the current performance? If you have a measure, get the baseline. How are decisions being made today? What is the current state? Then the next thing is to identify risks and mitigation strategies. We're going to touch on that later in the second half of the presentation to understand what kind of risks exist. We also have risks that we assess on the business side, which occur when we create the business case, but there also may be risks in doing the analytics. One key risk might be, is there data available? Is the data organized? Is it accurate, et cetera? That's a question that you need to ask at this point before you dive into the data, just simple questions like that. And finally, getting the agreement from your sponsors and stakeholders that, yes, if we solve this problem using this kind of analytics, that we will deliver value. The next domain, which is probably the place where you spend the most time, has to do with data. I have another presentation that I've done called It's All About the Data, where you really have to think about your data before you move on to any models and understand is what are your needs for data. Now you've talked about in the previous domain, we talked about the inputs and drivers. Now, what are the data that we need to represent those drivers and inputs? Where are the data sources? What are the structures of those data? Are they tables? Is it streaming data? Are they organized well as table? Is it spreadsheets? Understand how will that data get managed going forward, and finally get some data and start working with it, cleaning it, harmonizing it, doing merges and joins, and doing validation that the data matches your assumptions. Then related to that is looking at the data quality and looking for the relationships in that data. And then you want to write out and say, here's what our data findings are. Here's the quality of the data. What's the impact of it? What's the data management plan? And in the case of optimization, one of our best practices is we write a document that actually lists in it, here are all the tables, here are the names of the tables, here are the names of the columns, here are the types of the columns, here's how the tables relate to each other's and other assumptions we have about the data. So we make sure we have documentation about our data indicating that we really understand everything about it. And finally, you use that to validate and potentially update the business analytics problem statements. I should mention that while the domains appear linear, they're not necessarily linear. A lot of times you may have to go back as, for example, here, you might see that based upon the data that's available, you may now need to say, well, I got to change my analytics problem statement, or I might need to change my business problem statement because I don't have data that's going to allow me to support that actual question. So maybe you're going to solve a different problem because of the data that's available. The next domain is about your methodology approach. So now you're going to pick a methodology. Now we're going to focus here on optimization, but in the overall framework of the Informs Analytics framework, you could be doing machine learning or some form of AI, or simply just a project that will have some dashboards that lets people understand what's happening in their business. So now the first task is, of course, to determine the appropriate methods and techniques, and then evaluate and select which ones, given what resources you have and your data. Then if you're going to build something, before you've written a model, what is going to be the eventual architecture? How is data going to link up to your optimization model? Are you deploying in the cloud? Are you going to have to solve multiple problems? How will data get updated, et cetera? And then finally, you have to select a technology stack. In the optimization world, I like to think of that when you're building a solution for optimization, you're building a custom car. The car sits on a foundation of data. You can think of that as the wheels. Without any data, you cannot go forward with optimization. So that's why we have that data first approach. Then you need an engine. And in our case, we use Garobi a lot to be the engine that's going to be solving the problem. The engines can't do anything without a data. It can't do anything without the model, which we kind of represent here as the rest of the car. And finally, you need a user interface. How are people going to interact with the solution? So that's typically some form of a user interface. You can think of that as the steering wheel of the car. So you have to put all these parts together. The part now is, okay, I'm going to write a model. The model is going to be that custom car and its different components. Is it going to have what kind of sound system is it going to have, or is it going to have leather seats or not, or things like that. Those are all the parts of your model. Is it going to be blue paint or red paint, et cetera? All of that's part of your model that you're going to use, but that model is going to be dependent, is not useful without a user interface, can't do anything without data, and it needs an engine in order to be able to solve it. So now we go to domain 5, which is now you're starting developing your model. And this is where we do spend some time. But I should say that on most of our optimization projects, we spend less than around 10 to 15% of our time actually developing a model. Most of the time is spent with data, but also the other aspects that are in the other domains as well. So now you're going to design your model structure. You may have to build one or more appropriate models. We've had cases where we've had to build multiple models where they interact, et cetera. Now you're going to run and verify, evaluate the model performance, look at the outputs and see if they make sense in terms of the analytics problem statement that you've created. Then calibrate the model. Make sure that they get feedback from the users, from your clients. So you've now think you have a solution to the problem. Find out from the users if that solution is making sense. You may have to integrate multiple models if necessary. And finally, write documentation that says, here's what my model is. So in our best practices, we actually write out the math for a model before we write any code, and then we go and write the code. That document then is something that we can share among myself with my colleagues so that they can step in and work on the model as well in the future if we have to update it. And as part of that, we include our assumptions, our limitations and constraints that are about that model in terms of what it's able to do and what it's not able to do. The next domain is going to be the deployment domain. Deployment really has two aspects. So one aspect is the part that we think of, which is technically, is you're typically going to be building an application and standing it up and allowing, deploying an application into some environment. But the other part of deployment is you're building a solution that's going to get used by people in the business. How is it going to change the business operations and how people make decisions? Is it a decision support system that advises somebody, says, here's a bunch of possible answers, consider the best one? Is it going to be fully automated where it makes decisions on an automated basis? We had a client that has a system that runs 24/7. It solves an optimization problem every 5 minutes and it's in e-commerce. So in that case, what they're doing is determining what orders should be serviced by their different fulfillment facilities as the orders come in. So that's a different kind of application than one where we have a real user interface and the person's interacting with it. So as part of that, people are going to use that user interface and validate that with the business that the analytics solution is actually solving the business problem. Sometimes you have cases where you're, say, for example, building a supply chain network design solution, and you're recommending a particular strategic study. And that's now going to be a report that you give. It's not an application that's run every day. It's not operational. More strategic type of thing would be a business validation report that says, hey, the business agrees that this is going to validates that the solution that has been created with the model and the data is meeting the business needs, and make sure that the sponsors and stakeholders now agree with moving forward with the rest of deployment. That deployment then, what are the requirements for that deployed solution? How usable does it need to be? What does the business need to change? What types of things have to happen with the model? And then as it goes into production, you as a analytics professional or somebody involved with optimization, you want to make sure that this is going to be implemented and tested appropriately in production, and make sure that the deployment is validated and verified and that the data is continually flowing correctly. We've had projects where we've seen that data is what we assumed it to be, and then some back-end system is changed, and all of a sudden our data starts looking different, and that affects our ability in the application of the analytics or in optimization. And finally, the last domain is in solution lifecycle management. So in this case here, what you want to do is make sure that as your system is being used, that over time, that is continually you're asserting that it's delivering value. I had a colleague of mine who likes to say the statement that says that any system that's left alone for 6 months will be replaced by a spreadsheet. So in this case, you want to continually track the analytic solution performance. Make sure as things are changing, if business is changing, the data is changing, you may have to recalibrate your models. This often happens in the predictive world and machine learning, where you might see model drift because data is changing. You want to support training activities. How are people going to use this, both on the business side, but there could be other members of the analytics team that need to understand it as well. You want to continually validate the business case for the solution over time. Make sure that the solution you've created is continually delivering value. And look at the side effects of an analytic solution. An example that I've used in a number of talks are things like, if you're going to come up with a solution that's going to come up with better workforce scheduling when people are going to work, And the net result is that you don't need 50 people in the organization. That's a side effect that you might now have to worry about in talking to the various business sponsors and stakeholders and say, what are we going to do with these 50 people? Our solution is changing the way you're going to work. And then always making sure that your documentation is complete so that other people can come in and take it over. As an example of this, we actually have a project right now where someone built an optimization model for a client. They left behind no documentation of the model. The implementation is in obfuscated Java code, so we can't see what the math of the model is, but they need updates. And the firm that built it is not available anymore. So we have to go and rebuild the model. So if they had used this best practice, that would have made it much easier for us to come in and rewrite and come in with the new model with the new requirements. So let me also now map this to Princeton Consultants experience. So what you'll see here in the middle are the 7 domains. We've colored it a little bit differently just to show make it easier to map to the kind of work that we do. And what you can see here at Princeton is that we love to do these projects that are like at the top, the 3rd, 4th, and 5th ones, where we go from beginning to end. We address a particular problem with the client, understand the business problem, map it to an analytics problem, get the data, pick a methodology, build out a model, deploy it, and make sure that it's monitored over time. But sometimes we only end up doing some of the stuff at the beginning, and our client ends up worrying about things like managing the life cycles, like in the securities collateral. And sometimes we're asked just to do the stuff in the middle. So I'm working right now on this school scheduling optimization project for that particular client. They already understand their business problem. They already have their data very well organized. They want to improve their model. They're having some performance issues. They already understand deployment. It's already a deployed application that is used by their customers and how to handle things in the life cycle. Now, as part of doing that project, I ask the questions about all these other domains, but what we're being engaged to do is the stuff that's right in the middle. So what you'll see here is, our work really does span all these domains, but in any one of our projects, we always think about all the domains, even if we're only being asked to do a few of the things that might be in the middle. And you can see sometimes it's not even always about data, because sometimes we're handed data that looks just great. We still have to understand it, but we don't have to go through and do all those things tasks that are listed in the data domain. So now let me turn this over now, as I'm going to now want to start talking about how you manage risks for projects. What I want to get there, if you go and look at the Certified Analytics Professional exam, you'll see that what has been defined based on each one of the tasks are a set of subtasks, and these relate to what are called the blueprints for the exam. So you can see, for example, here, for each one of the levels of Essentials, Pro, and Expert, there are different subtasks that are more complex as you move up into more expertise for each one of the subtasks that are associated with the tasks. All of this is downloadable from the Inform site. We'll provide URLs at the end where you can see all the details of this. The reason I'm bringing this up is because there are 2 particular subtasks that I want to point out. One of them is relating to the business case and the business problem domain, which is the idea of identifying the risks to the business of implementing a solution. And you'll notice that at the expert level, you want to worry about risk mitigation. So we're going to be talking about how we at Princeton use what's called the Princeton 20 to address that. And then you'll also see that in domain 2, there's also a thing about the risks of the analytics solution. So it's the same type of thing, but now thinking of it from the analytics point of view. So how do we address this at Princeton? We use what's called the Princeton 20. And what we came up with, and this is really the brainchild of our CEO, Steve Sashihara, is 10 environmental factors which relate mostly to the business side that you have to consider, and 10 technical factors that typically are technical, and we have little icons for each one of them. For each one of them, what we do on a project is we give a score. The score basically says if -1, which is green, means, hey, there's no risk, everything is mature in that particular domain. 0 means there's things we have to consider and do some analysis, and 1 is high risk, mitigation warranted. So for example, if we don't have a sponsoring exec, that's pretty high risk for us, because who's in our case as a consulting firm, Who's going to be signing the checks and paying for our services? So that's, what do we do to mitigate those types of things? So we do this, we make a score for each one of 20 of these things, and this allows us to focus. So this is how we use the Princeton 20. All right. With clients, we basically score when we're writing a proposal, we research and discuss and score these different factors. And every time we have a +1, we have to come up with a mitigation strategy in our project plan. We don't want to we want to identify risks ahead of time so that we're able to address and mitigate those risks during the course of the project and not have it come as a surprise. We also use it internally. So we try to, when we're signing our staff to our projects, we try to create teams where if we know certain risks exist, we have people who are good at handling those particular kind of risks. And we also use it for staff performance reviews to see as we do annual performance reviews, how well our staff is mitigating risks that they've identified in projects. We look at after a project is done, we have after action reviews that basically tell us during the project and after delivery did we manage to mitigate these risks? How did we handle them? Were there risks that we didn't assess at the beginning, but now we found during the course of the project? Why did we miss it at the beginning? So we learned from that. So these are all our lessons learned, and this gives us stories and new mitigation strategies so that we can help and future projects become even better. So I now want to concentrate on a few of the factors. I don't have the time to review all 20 of them today, but I want to just pick out a few of them and show how they link back to this framework. So the environmental factors pretty much link right back to that first domain of business problem question framing. And I've pointed out two of the tasks here, which are creating an initial business case for a solution, and the second is getting sponsor agreement and stakeholder alignment. So if you look at things like the sponsoring business and sponsoring exec, that's all related to that task 1.6 about sponsor agreement and stakeholder alignment, as does resource availability and other initiatives in user engagement. They're involved in making those people. Resource availability has to do is are there other people at the client that are going to be working on the project with you? Well, they are part of the stakeholders. The business case is going to relate to understanding the business process. Are people really have a culture for making decisions and having a computer help make decisions? What are the scope of the decisions, the different key performance indicators, and the overall value proposition? So you can see here that those 10 environmental factors really link back to the tasks and the domains. And I should mention that these are two separate things that these were developed separately. The Informs Analytics Framework and the job task analysis from 12 years ago and the Princeton 20 were really developed independently, but they really link together. They're two schools of thought that are really quite aligned. So let me go over some examples in the environmental factors that you need to consider. One is a decision support culture, and you'll see here we write AI-based decision making. We do this because we also want to think about this when we have projects not involving optimization necessarily. So if you think of here, if I say optimization-based decision making, if we work with a client and they have another optimization application and it's helping them make decisions, that's great. That's low risk for us. Maybe they have it somewhere, but not for a decision that's related to a project. So for example, we've seen things where maybe they're using optimization to make transportation decisions, but now we're being asked to do optimization of a marketing spend. So it's not adjacent. So we have to kind of think about, like, do the marketing people understand how the operational things work? All right. Or is this the first time we're ever doing optimization? And this has to do with building trust. And so if we see that this is the first time we're doing something like this, the company hasn't ever had this type of application before, we want to have some high attention to human in the loop best practices. We make sure that the user interface is working well with data and allows people to understand the data. And then we reward user champions and storytelling. We basically say, hey, you haven't done this optimization, but here's your competitor is doing it, or other similar places where those kind of applications exist, and that helps us reduce the risk. So making sure that people understand what an optimization tool is going to do in terms of helping them make decisions is really important. And if we don't have that understanding, that's a risk that we have to mitigate right from the beginning. Another is KPIs. So understanding how are we going to measure that the decision that the system we build will actually be improving things. If that exists and we understand what those measures are, we're in good shape. Sometimes the KPIs uh, have been captured, but they actually, in terms of like how they've done things, we look at that baseline and say, can we easily resimulate how they made decisions in the past and then create those KPIs? So if they all know, if everything is recorded, it's great, but sometimes they've been captured, they haven't captured the KPIs, but they captured the decisions and we can compute the KPIs. But if they don't have KPIs that evaluate the decisions and can't replay how those decisions affect the KPIs, that's a risk. So then we have to talk to them about determining the right KPIs, do some good experimental design, and use a simulation, not necessarily Monte Carlo simulation, but just simulating the decisions and how they affect the KPIs, use machine learning to get insights, and also talk to the subject matter experts to understand the link between the decisions and the KPIs that are happening. Another aspect is user engagement, right? So if we're working with a company and everybody is under control of the company, of the sponsor, we're in pretty good shape. But sometimes the users are external users and they're not under their control. So as an example, we're doing a project in healthcare where our client wants us to develop schedules for patients and technicians. The technicians are under their control, but the patients aren't. So if they want to change a patient's schedule, they have to think about, well, we got to call this patient and say, we'd like you to change your appointment. How will that patient respond? So that's an indirect thing. On the other hand, if everybody's indirect, then we have to find out how will those users get engaged and how will they be affected. I'll give a case that we weren't involved in, but a good example of this is there's Apple. When they introduced Apple Pay, they created some machine learning to automate the acceptance of applications. That's affecting the real users, the people. And it turned out that there was bias in their algorithm. So you have to understand who your users are. We want to make sure is that there's a good user interface that it mirrors their best practices. Sometimes we'll build a user interface that mirrors their current systems and shows how decisions are made and what the KPIs are. We use agile processes for development and deployment, making sure the various users are representative. And we look and see what are the situations that are going to make sure that people are appropriately engaged for the solution. Now let me go on to the technical factors, which actually touch upon all the other domains, right? And I've listed just some of the tasks here. So for example, the primary measures of success are going to relate to your decision scoring. Data, of course, is a huge part as an entire domain. The decision selectable solution architecture and stack relates to your software tools and your user interface. And then requirements for a deployed solution is going to relate to AI process maturity. So I'm going to now choose 3 of those specific factors so we can review them. So decision scoring is, can we write a formula? Can we write code that is going to be able to evaluate the value of a decision? All right. Sometimes scoring the AI decisions is understood, but Nate is not crisp, and there might be trade-offs. The classic one in inventory planning and management is service levels. Is the product going to be there versus how much it's going to cost you to provide that service. So you sometimes have different KPIs that have to trade off, and you have to understand how people are going to evaluate those KPIs in there. And sometimes it's in scope for us to actually start scoring the decisions. How will we evaluate the quality of a decision? And in that case, that's a bit of a risk. So in that case, we do some workshops and say, how do you want to evaluate your decisions and see how they are, is a numerical value for them? We do simulation technology. So if there's a business process that's making decisions, build a simulator that's a digital twin of making the same decisions. And then we use human in the loop best practices. So we try to make sure that we don't build a black box that's going to make the decision. We basically build something that lets a human see what the decisions are and get confidence that and build trust in the overall optimization application. Another part of the Princeton 20 is, of course, relates to data. If everything in the data is there and it's clean, that's great. I mean, we're in good shape. A lot of times that the data is all there, and it's digitally available, but sometimes is that it needs to be cleaned, and that's usually often the case. We have to clean it, find issues with it, et cetera. And on the other hand, if it's in scope to determine whether the data exists and if it can be cleaned, that means we're going to have to spend a lot of time in data. Sometimes there's data that is in, people are making decisions, but they make decisions based upon data that's in their head knowledge. Well, now we have to capture that digitally. How are we going to do that? So we try different algorithms to try to see where the AI system works or doesn't work. Look for other data sources that might improve the signal, and look at the value prop in terms of determining if we start detecting the bad data, is that valuable? This can be a blocker if we're not getting the data right. And you can't be worrying about writing a model until you really make sure that all the data that's needed to make a decision is truly available, is well organized and well understood, and that the relationships make sense. You also want to make sure and understand how data was initially collected. We had a client that was in a trucking company. They have a system for their customer service representatives. A tender would come in and order to the company saying, hey, I want you to pick up a load from Los Angeles and drive it to Chicago. Well, the customer service representative has to make a decision, should we accept that load? And they had analytics behind doing all of that. But the customer service representative had to then, if they rejected the load, had a reason. And they had a pull-down menu where they would select the reason that they were rejecting the load. We looked at the data, and it turned out that 90% of the time, the reason that was selected was the first reason in the pull-down menu because it was the easiest for them to enter. And yet we could see, we knew that a lot of rejections were for other reasons because we talked to the business. So just a simple thing like that, how the data is collected, could affect your ability to do an analysis and to make appropriate decisions. Another one, which I referred to earlier, is this AI process maturity, is how well have they actually, and in this case, let's think of it from the perspective of optimization, is how well are they experienced and successful with deploying an optimization solution so that the businesses behind understanding if optimization can be successful. Maybe they have some experience in one area, but not in this particular one. Like the example I mentioned before, they might have it in certain operational areas, like in transportation, but maybe they've never done something in workforce scheduling or something in marketing. So understanding that, we have to worry about making sure that they understand that this is a technology that's been used in other parts of their organization and that it's safe to use it in their part. And sometimes maybe they've done some pilots, but they really have never done a production deployment at the intended scale. And remember, deployment includes not just the technical aspect, but really how are people going to make decisions using this technology. So what do we do to mitigate that is, we mentioned domain 7, you continually deploy and monitor what's happening in deployment and look at every stage of the life cycle, making sure that there's documentation, teach people the best practices, and make sure that the system is robust and easy to use. So these all, again, link back to the domains of the Informs Analytics Framework. So here's the list of the Princeton 20 again. As Mike mentioned, we'll be sending a copy of these slides to everybody so you can get these links, or you can just Google Princeton 20. You'll find 2 blogs that we wrote back in 2019 about which was optimization. At that point, we weren't using the words AI. We've added AI because we found the same concepts apply to our machine learning projects as well. So you can read more in depth about the 10 different factors that we use here. So I want to summarize, and then we'll open it up for questions, say that the framework that I've provided is really a set of tasks that you should be addressing in any one of your optimization projects. And a key component of success is risk mitigation, looking at the different risks that might occur, assessing those risks ahead of time so that you understand and plan for them as the project proceeds. And our Princeton 20 is providing that methodology for assessing the risks. So with that, I'll turn it over for any questions. As Mike mentioned, you should be asking your questions via the Q&A panel that is in the Zoom.
All right. Thanks, Irv. And we'll start with first question is, um, what value does Princeton find in building optimization and analytics solutions in an iterative and incremental fashion, a la many agile methods? Would each increment walk through each of the analytics framework domains and result in a partial but functional analytics solution?
That's a great question. So we do use Agile for our development, but I would say that it's not used in all of the domains. I mean, yes and no, right? We're starting off and defining a project. I mean, we're being agile and saying, okay, in this sprint, we're not worrying about any code. We're worrying about getting the problem and the documentation right or the analytics right. But pretty much once we have the problem defined and now we're working with data, there's going to be sprints in Agile that we're working with data. Now we're getting to the modeling part. All right. So let's say we've chosen to use optimization. We're going to start building out a model. At that point in time, we are using Agile. And what we will be doing in that case is saying, here's a set of requirements that we can develop, and we can show a solution that is handling that set of requirements. We'll have a user interface that lets them see we're handling this part of the data and these requirements, and it's getting a solution. Yes, it doesn't meet these other 10 constraints. We're doing those in future sprints, but it handles this set of requirements. So it is a partial and functional solution that allows the owner of the project from the Agile perspective to basically say, yes, we can move forward. You've met these things that we've agreed to at the beginning of the sprint. We tend to work on 3-week sprints with optimization, not 2 weeks. We also have to make sure that people understand that once we're getting to that part of developing the model, that there is a bit of a research component, that we may be trying different ideas to see what's going to work. So it may be that at the end of the sprint, we're like, we tried these 3 ideas and they didn't work. We're going to move on to idea 4. And we have to set those expectations ahead of time. That's part of our experience in project management and communication, that, at the beginning, we understand what the risks are in trying one modeling approach versus another. So that we can avoid those kinds of conversations. But in general, going back to your questions, we do go in this iterative fashion when we get to that modeling part, but usually assuming we haven't had come back and, like we got the data and we have to change the business problem, we are kind of linear in the sense that we'll get the business problem, the analytics statement of it, work with the data, figure out what optimization technology we're using. Maybe often we're going to use Gurobi. Sometimes we have to build some heuristics as well, or we have to build an algorithm that involves Gurobi. And then we get into that model development phase, and then we try to be incremental over there.
Okay. And we've got another question, and we have a few more, Irv. First is, are there templates for user interfaces to get that part up and running faster?
So what we've used in a couple of projects, a tool called TaiPy. It's TAIPY. You can Google it. I've actually done presentations on their behalf. We're a partner of TaiPy as well. They have an open source as well as an enterprise version. What TaiPy is really great at is that you can have a bunch of pandas tables, and in an hour, you can get a UI that displays the tables. In a few days, you can get a functional UI that allows people, you have an optimize button, it calls an optimization thing, produces an answer and puts an answer in. So we have found that really quite valuable for demonstrating that we're making progress. And you can create some pretty fancy UIs with TaiPy. What's nice about it is it's pure Python, so we don't have to worry about writing any of the Angular or React or JavaScript code, TypeScript. It takes care of all of that. It's just pure Python. It uses combinations of Python and Markdown. So that's the tool that we've used in doing this. Now, when it gets to delivery of a project, it's a little bit different. And the reason is that the clients typically have specifications about how their user interface design works and how their user interface code should integrate with their applications. So as an example, we did a project for a company and we did the TypeI user interface so that during our agile process, the business sponsors and project people could validate that we were doing everything right. But this actually user interface had to act as a tab within a set of applications at the company, and they had standards for how that works. And they said, no, we don't want to use a third party. They hired another guy who wrote the same user interface we had provided, but using their standards, and then called our REST API in the back. So TypeI, we've used it in other projects again like this, and then whether it becomes the final user interface, for us that hasn't happened, although I know for a lot of TypeI's customers it has. So that's the kind of the tool that I like right now, because I can do everything in Python and not worry about all learning all the tricks of Angular and what have you.
Okay, and next, sometimes projects involve both AI, forecasting demand, for example, and optimization. How do you handle that in terms of data and project management?
Well, so I guess let's presume here that AI is, let's refer to it as machine learning. There's Gen AI, which is a whole separate topic. But let's assume that we have both. So in that case, again, it goes back to starting with the business problem, understanding the analytics problem, and then saying, hey, we want to be able to use some kind of forecasting or something like that from machine learning that becomes an input into optimization. So we did a project for a trucking company that involved multiple machine learning models and multiple optimization models. There was a huge diagram that I wrote up on a board that had all these arrows about how this model produces output that becomes an input for another model. So we do that as part of the design of the solution process, and then start to the actual development of it, and making sure that we're always trying to deliver value. So one of the things I like to say is we've got a fantastic toolbox out there, right? From machine learning, Gen AI, to optimization, to simulation, et cetera. So what we don't do is we say, despite our friends at Garobi would like us to say, is we don't say, we've got Garobi, we can solve your problem. What we do is we say, let us understand your problem, and then we're going to pick out the right set of tools for doing that. And that tool for optimization often is Garobi. But sometimes it's not an optimization problem and it's a machine learning problem. So then we'll typically use open source for doing that. And then we'll find an open source tool that can meet our needs, that's easy for us to use, that can deliver value. But we have a big toolbox. What we don't do is we say, we've got a hammer, let's find a nail. We find the nail, and the other things that we have to find the nail, and then we pick out the right hammer or right tool to attack that nail.
Okay. Next up, hey Irv, thanks for a wonderful presentation as always. I am curious how often you face the challenge of clients hesitating about solver costs, if at all.
I would say that it kind of depends how we're coming at it. If we're coming into a fresh project, where we eventually figure out as we go through the domains that, okay, we're going to do optimization. And if the way we work with our partners is as follows: if we got the lead, in other words, a company gave Mike a call and said, hey, we got this thing and we're moving all through it, we're kind of free to choose the solver that we think is going to best solve the problem, and it's often going to be Garobi. On the other hand, we are partners with Garobi and FICO and IBM and Google. If they bring us a project, we're going to use their tool, and that's the way that we make sure we maintain our relationships. But in all of those cases, typically the cost of our services for implementing a solution far exceed the cost of the cost of the solver. So what we are telling for us, and we're thinking about doing all of those things in the domain. The cost of our services, we are going to build a solution, and the solvers kind of come along for the ride, and the solver ends up being a relatively small cost to the total cost of implementation. And that total cost is not just the fees that we're going to charge; it's actually internal costs, right? Maybe they have to go out and start standing up some cloud servers for this application, or they're going to have to hire some people that are going to be working with this application internally. There's other costs that go beyond the solver cost, which ends up really what you end up seeing is that the solver cost ends up being a small part of the overall cost of a project. And it's kind of analogous to a car, like I used earlier. If you looked at the cost of the parts of your car, the engine it's a big part, but it's small compared to the overall cost of a $30,000 vehicle.
Okay, next up, for Princeton Consultants specifically, how do you usually negotiate pricing with clients? Do you base it on a fixed fee or a percentage of the cost savings achieved? And what approach would you recommend for a new consulting company that is just starting out?
Well, I'm not sure I want to answer the last question, but but for the first two, so we generally do our projects either as time and materials or fixed fee. So in the case of time and materials, that is incumbent upon us for estimating how much time we think is going to take to deliver the project. And if we are with the understanding that, especially because we use Agile, that we say, hey, this is what we're going to do, but we're using Agile. If you add new requirements, that may require more time. So when we kind of understand, if we can really, so in that case, what's happening there is they're paying for our time. And it's our responsibility, of course, to make sure that we're making progress as the time proceeds, et cetera, et cetera. But at the end of what they signed up for, right, they have to make a decision of, are we going to pay for some more of your time? Now, if we've done a good job, we've estimated the time right, we've delivered everything in the time that we said it would, and everybody's happy. So often there's change requests, and that adds more and more time. The other type of project is one where we will do it as a fixed price. And in the case of a fixed price project, what will happen there is we have to make sure so that we are charging an amount that will incorporate what we are assessing as the risk. So if it's fixed price, then we're going to say, these are the things we're going to do. And if you're going to do Agile, then if we said we're going to do, items 4, 5, and 7, and you want to take those out and replace it with items 14, 15, and 17, that's fine. You have to do a trade, but 4, 5, and 7 are off. If you want to add, well, that's another fixed price project to it. So what we do is in the fixed price projects, we try to say, here's what we're going to do. We then estimate what our cost and our time is to do it. And if we can't deliver it in that amount of time, that risk is on us. We have to basically, it's a sunken cost for us to be using extra consultant time to deliver what we said we were doing. So, we do price things both ways. For your, the second part of your question was, what approach would you recommend? I would pretty much start with time. I think time and materials is easier to do, but it's tough. I mean, I'm hesitant to personally answer that question because I joined a firm 10.5 years ago that had the experience. I would say the change that I've seen over that time is we tended to do more time and materials projects when I first joined, and we now do more fixed price projects today. But it's all over the map, and I stay out of pricing. I leave that to our CEO, Steve.
Okay, next, for Princeton Consultants, after completing a project, how long do you typically provide maintenance or follow-up support for the client?
It's all over the map. We have some clients that will go and hire somebody with the right kind of background that we will then do a knowledge transfer to, and they handle all the forward-going maintenance of the project, and we're done. We have others where we've had some, I think, that have gone on 10, 15 years of a continual support contract on an annual basis. And it kind of all depends upon how thing is being used and how it's being evolved and what kind of changes are being needed. Some of them are getting up quite stable that they just kind of want to have us on call and pay for our time if something goes wrong, but nothing goes wrong, so we don't get called. So it really goes all over from total knowledge transfer to where project's done, we're done, to having an ongoing maintenance agreement and support agreement for the client. We have one client right now that we're doing support for. We have a support agreement, They're in the process of a pilot, and as it's rolling out to more and more facilities. And that scope of that is, okay, we will fix bugs and but we will not do new features. New features is a new statement of work because that's an additional set of work. And, it's a negotiation of like what consists of support versus new features. We're hoping with that client, as it continues to roll out, that we'll be doing support for a number of years, but we also anticipate possibly at some time that they might say, hey, we're willing to take this over. It all depends upon the client and, our relationships with them in terms of supporting and how complex the project is as well. So it's really all over the map.
Okay, next, how familiar are organizations with Python? What level of technical abilities of the clients can we expect these days?
Well, we are using Python all the time, and we have found really no resistance to doing it. Clients are onto it. I mean, they're using Python. They've using it in lots of different ways, sometimes in things that have nothing to do with optimization. I mean, you've got major websites that are being run on Python backends. So that hasn't been an issue. We did have a client, I think this was about, I guess it was pre-pandemic. Yeah. So about 6 years ago in finance. And at the time, they were not allowing Python at all. And so we were developing a model for them. And because it was in finance, systems are very secure, et cetera, et cetera. So they do everything in Java. So what we did is we said, okay, look, we're going to write this. If you want us to write Java, our price goes up because we're not as productive writing Java code for optimization as we are writing Python. So we said, we're going to write this in Python. We'll document our model. We're going to write the code in Python. We're going to assume the data is in the same format that it has in Java. And then their developer translated our Python over to Java. And then if he ran into trouble, he could actually send us we were doing this with Gurobi, his MPS file that we could then look at and say, and his data. And we could run it locally and say, well, wait a minute, our Python code produced something different. Why was it different? Hey, you have a bug in the Java. So, but otherwise, we have not really seen any resistance to using Python beyond that one case I just mentioned. Clients are using it. I think the degree of sophistication in developing an application with Python is very varied. And so this is one of the issues that we see is that we actually see it in some of our hires is that people are often learning Python in the notebook environment. And that's great for experimentation and POCs, et cetera, and data exploration. However, when you're delivering an application, you got to get out of the notebook. And so now you have to think about more object-oriented programming concepts and application design. And the same principles apply whether you're using Python or Java or C++ or any object-oriented language. So what we see often is that people are familiar with Python at the notebook level, at the experimentation level, but when it comes to actually building a real application, that's sometimes where we have to fill some gaps.
Okay, and we have a few more, but I think we're only going to be able to take, Irv, I think a couple.
Okay.
So I'll ask to you
And then I think on any of the ones that we haven't answered, I see a lot of them are coming in as anonymous, but if you do have them, you can send an email afterwards and we'll be happy to answer them.
absolutely. So let's see. In an optimization project at Princeton Consultants, how large is the typical project team and how many people are usually involved?
It varies. Usually there's 2 to 3 people. We'll have an optimization person, right? It might involve 2. So there might be like myself as a senior person that will be supervising the work of one of our junior consultants. We'll have somebody typically involved with data. And sometimes the data and user interface things are covered by the same roles. As if the project's more complex in delivering an entire solution, we might have people that are just involved in database and total backend plumbing, if you will, types of things, and also project management. So it ranges from, on the projects I've been on with optimization, it's ranged from typically from 2 to 5, 6 people rarely, but somewhere in that range. I would say typically it's around 3 people that are involved.
And Irv, I will add though, we do have a current work with a client where they have there are a couple of teams and that we have personnel working on those teams where there are client team members and then our team members, and that the makeup of those are slightly larger than
Right,
what you just
right,
said.
right.
Yeah,
And those are not necessarily all optimization projects either.
right. Okay, last question. For Princeton Consultants, how long does it usually take to complete a project? Could you give a typical range?
It kind of depends. If we're doing one of these things where we have to do it from beginning to end, right? So we got to understand the business problem, analytics, and there's data and what have you. That could be anywhere from 6 months to a year, right? If we're doing a project where we just have to improve a model within an application that's already been developed, that might just take, 3 to 4 weeks. But so it ranges the gamut. We have this one project that I mentioned is now in pilot. We started that project in 2020, right? And we actually did most of the work from the fall of 2020 to the summer of 21. It then went idle for a bit because they had to get their data systems updated. That took 3 years. And now we're finally that the data's ready. We're now into this pilot phase where now we're getting real data and we're starting to find little bugs here and there, and the users are using it and getting feedback, et cetera. So a lot of times the timing, of it will very much depend upon other things that are happening at the project. If you remember, one of the risks I mentioned on the business side is other initiatives. In that particular case, the other initiative is they were changing their data systems and they were implementing Salesforce. We actually implemented the Salesforce connector in the summer of 21 and it was tested, but the Salesforce implementation and rollout took another 3 years. So we waited and we waited and we waited. And finally, the rollout was complete last year in 2024, and that enabled us to now move forward with the deployment of our part, which was dependent upon that data coming from Salesforce.
Okay. Well, on that, we have a few other great questions, and we'll get back to those, or you might have to email them if you posted them
I think it'd be best
anonymously.
to
But
email because
yeah,
if you didn't give us your name, we don't know who asked it.
that's right.
So you'll have to send
Send
an
us an
email.
email. We'll be sending the slides shortly. That's all the time we have right now for this webinar. But thank you, Irv. Thank you for all the folks for attending. And we'll look forward to continuing the conversation. We'll be sending out the slides shortly. Thank you and have a great day.